Hello and welcome to the Clarkdale Smart Towns Park presentation. We're a group of students working alongside Clarkdale Project Cities and EPICS through the FSE 104/404 class. I'm the project lead. My name is Philip Kye.
My name is Audrey Schlichting.
I'm Non Kaudakumpong.
My name is Ashwin Mandrekar.
All right, as we begin our presentation, we'll start with some background info about the park that we've been working on, the Salnamanjini Park, and also providing a brief project summary of what our tasks were this past semester and what we were planning to accomplish as a result. So the park that we've been working on is the Salnamanjini Park. As you can see, the current Salnamanjini Park is currently two parks right now. It's the Salna Park and the Manjini Park, but they plan to combine those together into this proposed layout that you see on this bottom slide. The purposes of this park, or the goals of it, are to promote healthy community, youth engagement, community beautification, and sustainability. Currently, the soil is going under remediation and they are beginning to lay the groundwork for the park. And our job is to provide some physical and digital features that will enhance these goals for Clarkdale in this park. And so our project summary will be going at it from a top-down to a more specific setting. So the first main goal that we're trying to accomplish is to assist Clarkdale, Arizona in accomplishing the community engagement goals with the Salnamanjini Park. To do that, we're going to develop digital amenities that will promote visitors to the park and also promote community engagement. The digital amenity that we're going to be focusing on specifically, or that we did focus on this past semester, was developing a Wi-Fi system to draw people into the park and to use it as a framework or sort of a foundation for new designs or amenities that we might have for Clarkdale in the future. And so here is our plan for the Wi-Fi, or what we worked on this past semester with the mesh Wi-Fi system, also talking about our hardware options, the additional research that we put into those hardware options, and also providing some rough schematics to kind of help you visualize what the Wi-Fi system will look like.
Okay, so the Wi-Fi system that we're going to use for the park is called the mesh Wi-Fi. It's very suitable for the park because it can extend its range based on how many access points it has. So it has to have the main access point that connects to the internet service provider, and then it will connect itself to other access points in the park to extend its range. And all nodes will communicate with each other and will optimize the closest range from the device to the closest access point in order to have the most stable and robust connection. The problem of this, the only downside for this mesh Wi-Fi system is if you are to move from one place to another, there will be few seconds of no connectivity in order for the access point to recalibrate closest access point, the next closest access point to the device. This will ensure that the device and the client doesn't have to reconnect to another SSID in order to still have the most robust connection to the internet. So this is our hardware options for the access point that we have. The one we have chosen is the rightmost one, the Meraki MR76. We want our access point to be future-proof or even present-proof, because most of the device, especially phones and laptops, already have Wi-Fi 6 enabled. So these 5 models that we deemed the most compatible with our system, 2 of them which doesn't have Wi-Fi 6 are out of the picture. The Max client is not an issue for most of our access point that we have, since the park can handle, the park requirement is 400 Max clients, and The only one that doesn't have that is AP1130, but that doesn't have Wi-Fi 6, so it doesn't matter anyways. The problem of Meraki MR76 is that the operating temperature is a bit low than what is the environment in Arizona. So we will provide you with, so in our plan, we will have a box that contains the Wi-Fi, the access point, in order to let it operate in the optimal temperature. The thing that separates the Meraki with the Catalyst is that it has the cloud management. What cloud management is that you don't have to be on site in order to manage the access point. That means that it's easier, much easier to provide like maintenance, or if something goes down, you can be from further away to troubleshoot the problem. But that comes with a price tag of a subscription that is $400 per 3 years. But if you want to extend it to 10 years, for example, it will be much cheaper than this. So we're down to two choices, the Meraki MR86 and the MR76. The MR86 is suitable for more dense environment, like offices and inside buildings and like outside buildings that have many buildings around it. Compared to the MR76, that is more suitable to open campuses or parks. And it comes with a lower price tag of almost half the price of MR86. That's why we've chosen the MR76 as the most optimal choice.
So we will be using the Cisco Meraki MR76. For this, all we need to do is buy the number of access points and the licenses for all these access points. Some of the features of the Meraki MR76 are multi-site management. So a powerful and intuitive multi-site management, which is done via the cloud, eliminates the cost and complexity of on-site wireless controllers or centralized management tools. It has zero-touch provisioning, which shortens the deployment time and configuration to minutes. There's no need to manually stage the APs or perform manual configuration and provisioning. The Cisco Meraki APs also makes use of auto radio frequencies to self-configure and optimize RF settings for maximum performance, even in dense and challenging environments. So it is also future-proof. So seamless over-the-web upgrades deliver significant new features to the current products. New feature updates are added automatically, such as visibility, analytics, security, and troubleshooting tools to enhance administrator efficiency. It also has unmatched visibility, which means administrators can also quickly create access control and application usage policies to optimize both the end user experience and the network security. It also has the entire network under one roof, which basically means it unifies the WAN, LAN, wireless LAN, and mobile device management under one roof. So for the Meraki access points, we are going to be using the omnidirectional antennas, which typically reach a range of at least 100 meters. A lot of these range also, it depends on multiple factors, such as radio frequency interferences from nearby towers or physical obstructions like trees and weather changes. All of this makes it difficult to tell the exact range, but we can expect a range of around 100 meters, which is 328 feet. So this basically means it also can handle 500 people at one time without losing performance.
So each one of these systems is represented by one of these gray brains as the access point. And the red circle represents the range that can be given with each one of these access points. So as you see on the map, We have approximately 11 of these access points distributed throughout the park. And each one of these is carefully calculated based on the acreage of about 40 acres for this park. So these, as Nat was saying earlier, are to protect the Wi-Fi system from overheating. So each one of the access points will be encapsulated by one of these boxes. And this will protect it from different weather and specifically the temperature in Arizona, since it is a warmer climate here.
All right, and here are our next steps for the Wi-Fi plan and for other amenities that we have planned after this fall semester. So first thing we're gonna probably kick off with in spring 2021 is developing a more detailed schematic for the Wi-Fi system. We're thinking of maybe a 3D diagram, something with more hard numbers so that it would be more beneficial for our stakeholders and for our community partner. Next, we want to finalize all of our hardware components. These are the production components. So we're gonna have a bill of materials ready and also have a full cost analysis detailing exactly how much we should expect this whole system to be running for. After we have those things ready, we're gonna start producing and testing a prototype of the Wi-Fi system. Some tests that we wanna start out with is testing the range of a system, the bandwidth of the system, and also testing around the Wi-Fi box that we saw in the previous slides and trying to get some more hard numbers from that as well and seeing which configuration would be the most beneficial and the easiest to manufacture for the Wi-Fi box. Once those are all complete, we can hopefully also begin conceptually designing new amenities for Clarkdale, whether that's in Selma Mangini or in other areas of the town. Thank you so much for coming and seeing our presentation, and now we'll open up the questions.